Next up, we have virtual Bob Gerzoff, WK2Y.
Good afternoon. Can everyone hear me?
Yes, good audio. Yep.
Great. I'm Bob. Let me start off by thanking Nathaniel, my co-author on this, mostly for putting up with me. When he and I got involved, I don't think he realized just how many naive questions I would be coming up with. And I'm also a pain in his rear. I also want to apologize for not being there today. The medical establishment decided that I needed to have a Yagi embedded in my back. If those of you who want to do this as a DIY project, there will be details in next April's QST and the December BMJ. I'll also be holding a special event station with a certificate and special QSL card. A little about me, licensed back in '71. I live in Atlanta. And if you want to get in touch with me, I am up to date on qrz.com. I come from a different arena altogether. I put the citizen in citizen science. My background is environmental and public health statistics. I retired in 2016 from the CDC. My training in statistics has me looking for general factors as opposed to special factors, meaning I'm looking for causal models that apply generally in a wide variety of situations. And that's how I approach statistics and how I've approached looking at the WSPR data. I started this work a couple of years back and had been frustrated basically because I was only finding noise, and Aidan, maybe you have explanations for that, and we might want to talk after this, but I noticed that the models that were being used were, although they were causal models, people were looking in particular at traveling ionospheric disturbances, were relying on counts. And within that same body of data, particularly the SNR data, there was a lot of unused, in the WSPR data, there was a lot of unused SNR data. And it's a continuous measure, and it should be usable for developing predictive frameworks. And consequently, my mind went and said, look, why can't we use that to accomplish some of the things that others were trying to do with just counts? A naive approach, perhaps, but one that I firmly believed in. There was also, and as time has gone on, the amount of data that is available is accumulated extremely rapidly. And I'm reminded of a story that our 40th president used to like to say about, if you see a pile of manure, start digging because there's, in all likelihood, a pony underneath it. And I had to believe that underneath all of this SNR data within the WSPR data, there was useful information. And I wanted to torture the data, see if I could find out exactly what it might be able to tell us. So my approach was, because I'm coming from an uninformed public health background, was to start torturing the data. And as I mentioned, my first attempts have not been that successful. I found a lot of noise. I also found a huge amount of variability within the reported SNR data, within WSPR data. And I'm excited to have heard Dr. Quinn's presentation about being able to possibly eliminate another source there about with the noise from out of that data. So from a statistician's point of view, the biggest issue we have is that we have an infinite number of confounding variables. nothing is the same when you look at two observations. The solar environment changes, the meteorologic environment changes, station configurations change, the time of day changes, there's geographic changes, the list goes on and on and on. So what we like to do, therefore, is control for as much as possible. My approach, therefore, was to take a look at a single mode, not combining reverse beacon network CW information. Just look at the single mode WSPR and look at matched stations on the same band and look at stations over the smallest possible time interval. This is sort of akin to what they might do in a clinical experiment where they try and match patients, where one gets a control and one gets a treatment. So I looked at all 20-meter WSPR observations in 22, and I reduced the data set down by finding all observations between pairs of stations that were within 2 minutes of one another. In other words, if those of you who are familiar with WSPR, those are sequential WSPR contacts. Ideally, I would have them at the same exact time, but with the data that we have, this is as close as we can get. And once I've identified a pair of stations that are sequential in the database, I take the difference between the two sequential values in their SNR reports. For 2022, that resulted in 189 million something, or almost 190 million paired difference observations for the single year. That's an enormous amount of information. And as I said before, I have to believe there's got to be some useful information for causal modeling that can be unearthed from that. When I did this previously, back in with 2017, I only had 2 million observations, which still, from a modeling perspective, is a lot of data, but now we have tons and tons of it. So there should be some way to unearth something from these data. And if I have one objective today, it is to prove, or as best I can prove to you all, that these data can be used, even if they are not perfect. These data can be used to uncover patterns and perhaps even be used for causal modeling down the road. All right, so we have that 190 million paired observations. That represented 1 million, let's call it 1.6 million unique station pairs. Now there are issues with this data. 20% of the data are exchanges between just two stations. And this is something that if anybody's going to use these data, that needs to be kept in mind. So we have an issue with, possible issue with duplicates. We have also an issue with a lot of the data being represented by just two stations. For this analysis today, I am just ignoring not this overlap or this large portion of the data that's represented by these two stations, ignoring it because their variability between these two relatively closely stations was fairly close to what the overall pattern was. So let's get into the data here. And the mean difference that we found, if we were in a perfect world, would be 0. I understand because of scaling and possibly some other transformations, the difference between two sequential reports turned out to be 0.59 dB from the SNR reports of WSPR. The standard deviation, and this may not be an appropriate standard deviation, as Aidan just pointed out, but I'm not quite sure how to apply it to these kind of data, was 17.8. So you can see that we have from a minimum of minus 75 to a maximum of 56 dB, some, let's call it extra Gaussian variation. Now, some would say there's got to be a problem with the data. I would say my reply to that is that there are two things that bother me about that. One, we have a substantial portion of the data and substantial regular observation of the data that have these types of numbers. So they need to be accounted for, even if, and it could be something about our WSPR software. It could be something about our SNR measurements within the software. It could be something about our reporting system. One way or another, but still, we have a whole lot of observations, which, to my way of thinking, makes me think that we're observing a real phenomena, and it probably warrants some kind of explanation. For this particular study, I was interested in the outliers, those large variations, and seeing if I could uncover something about the outliers in particular. So I divided the data into what I call extreme versus non-extreme observations. Here I said the top 1%, I've got plenty of data, so I'm going to take the top 1% and say if I can figure out what might be related to those top 1% of the observations, the top 1% of those SNR differences that are very, very large. I then modeled that data using logistic regression to predict the probability of extreme observations. And a logistic regression is a form of regression, and the only thing you need to know for this particular presentation, it's the probability of, it's going to predict the probability of those extreme observations. As my predictors, because this is what I had, I used hour, month, distance, and I modeled all of them as categorical. I want to come back to that in just a moment. I also adjusted for the average SNR, the average of the two stations, the two reports from the same stations, same station. I averaged their SNR and included that in case the differences were related to the overall power level. Because I have repeat observations by station pair and date, my model also accounts for that. That does not affect really the predictions. It really only affects the confidence intervals around the observation or around our predictions. Now I want to get back to that business about looking at categorical. I model things as categorical because I want each one of the months, each one of the hours to be able to make its own independent prediction. I don't want to assume any kind of model, if you will, about the relationship between those extreme observations and the time sequence, whether it be in the month or in the hours. I don't want to assume a sinusoidal. I don't want to assume a seasonal effect of any kind. I want to let each month stand on its own. I want to let each hour stand on its own. I have plenty of data, so I'm going to let it do it. Because if I assume a model, I'm going to get a model that probably fits with this amount of data. And I always like to put this up, especially if we have young people in the audience. Each one of these lines that you're looking at here has a correlation of 0.82. And I particularly love example number 4, where that correlation is basically all dependent upon one point. Especially when you get to larger data sets, it's very, very difficult to know, and multidimensional problems, it's very, very difficult to know what the relationships actually are, and consequently you have to let the data talk for themselves, and hence I use categorical modeling, not continuous model assumptions for my parameters. Because I'm a statistician, we have to have a model, at least a shorthand model here. This is the model for the logistic regression, and I won't dwell too much on that, except we do have a term, mentions we have terms for the month, the hour, the average SNR, the path length, rounded to 500 miles, a term for our clustering by pair and date, and in random error. Because we have so much data, p-levels, significance levels in terms of predictions are pretty meaningless. Everything will become significance. Consequently, what we want to do is look at predicted margins. And I quote here, margins are statistics calculated from predictions of a previously fit model. And here's the important part, at fixed values of the other covariates and average and otherwise integrating over the remaining covariates. I call it semper paratus predictions. If we take the average hour, then what is the average, then what is the difference that the months make? If we take the quote unquote average month or the distribution of the month, what is the difference that the average hours make? It's a measure of effect size. And these things, now that they are easily calculable in most statistical packages, are replacing p-levels pretty much everywhere. So before I get into the results here, again, my point here is not to develop a particular causal model. My goal here is to show that you can, with the right finesse, with the right modeling, with the right approach, use our SNR data, even as I think Gwynn used the word compromised as it is, to find things within the data. Now, my approach is naive and it's limited. But if we can do ask of the data some informed questions, we might get to some underlying causal principles. And I believe that the SNR data could provide the answers to those causal questions. So here is the predicted adjusted marginal probability of an extreme distance between two 2022 sequential 20-meter WSPR SNR reports by hour. The important thing here is there is a pattern. I don't quite believe this dip down here, but certainly a pattern exists. The y-axis, which is the predicted probability, is predetermined by my having chosen that 1% cutoff. So it's not really relevant, but the pattern is. Similarly, when we look at by month, we see a pattern by the months. Again, y-axis is determined by my ad hoc decision to use 1%. But there is a distinct pattern here of seeing an extreme difference in SNR, two sequential SNR reports by month. Very nice small confidence intervals because of the large sample sizes that we have. And here is the distance measures, same concept again. The point is not the particular shape of the model, but the fact that we do get a model, and we've gotten that model out of the existing SNR data. Here is a interaction between month and hour, which basically shows that the hours are the different lines, the months go across the x-axis, showing that we have slightly different values of the predictions, slightly different probability of an extreme event for different hours by month. So, conclusion, the SNR, the existing SNR data, compromised as it may be, despite all the complaints, does evidence patterns. What I've shown here are only distal causes. They're not proximal causes. They are not, hour does not cause the changes that I observe. There's something behind hour, something further causally upstream that is causing those. Months do not cause the patterns that we saw. There's something further upstream. And I think with the right approach and the right methods, we can get to those causal mechanisms with the existing data. What I would like to do is become more informed and develop a research agenda for using the data that we have. Perhaps we go over to WSPR Daemon and maybe we do something with that. But regardless, I think an informed research agenda would very much help the causal efforts that so many folks seem to want to get to. And I would ask if you are interested in that, and if that's what you would be interested in, please drop me a note, and we'll get an informal working group going and keep the meetings to an absolute minimum. I did also want to point out that a colleague of mine, Vincent, KF6FLJ, has a poster on the effect of an X-class flare on 40-meter propagation that uses the SNR data. So please do stop by and take a look at that. It's at least another, shows the evidence again of how we can make use of this data for further investigations. Thank you very much. I appreciate your time.